Hello everyone, this is my final project for Info 490. I created a fake news detection algorithm or model, and I was really seeking to solve the problem of sorting through all the information that we see today on social media, news sources, emails. It's hard to sift through what information is true and what information is false. And I even find myself wondering sometimes if I'm believing information sources that are not true. So that is the problem that I seek to solve with my final project. Review of the project analysis and data preparation, I have another notebook linked in the metadata section, which is where I load the lengthy training data, and I prepare the data by making it all lowercase, filtering out any numbers or weird characters, things like that. I stem the words and remove any stop words, and then that cleaning gives me a corpus, which I then pass into the TF-IDF vectorizer, and I will go into much more depth in that in the other notebook. This is all done in a separate notebook, which is also linked in the metadata section of the previous notebook. So I did all the necessary imports and downloaded the training data. And then just to clean it up a little, I dropped any null and unnecessary values, like the author was not really important to my analysis, so I dropped that. The title was not necessary for the actual analysis of the article, although I did save it to perform some analyzations of the length of the title a little later on. And then I just save the labels for testing later on as well. And then this is just a little bit more cleaning up and restructuring of the articles to get ready for analysis. Exploration, I find the top 10 most common words in the fake news articles, and you can see those listed below. I, of course, filtered out stop words as well as some other words that would not be very relevant. But yes, you can see those listed here. And then as another data exploration analysis, I found the lengths of the titles for the fake and real news articles, and I do some more analysis on that, as well as the lengths of the articles in the other notebook that you can see. So I start by looping through each article and getting the text from that article. Then I remove all numbers from the article, as well as punctuation and non-alphabet characters, and then I put the text to lowercase and split it into each individual word. And then as you can see here, we store the cleaned articles into a variable, and this is what the first article would put out, all these words. And then we can, from there, stem the words to using the snowball stemmer, and that will just kind of make it easier for the vectorizer later on. And so yeah, I basically loop through, do that for each article, and then store that into our corpus. And then I here have printed out just the first corpus, and we can see that we have these stemmed words. We have stemmed the words. We can now pass the corpus into our TF-IDF vectorizer, which is the term frequency inverse document frequency vectorizer. And basically what this will do is tokenize the corpus and sort out the words that are most important to the corpus. And that is what we will store into X. Now that we have our X, we can pass the X and the actual labels into our train test split method, and that will give us our training and our test data here. And once we have that, we are ready to fit our model. The first model that I tried out was the naive Bayes. So I make a multinomial naive Bayes object, and then I fit the model to our training X and Y data. and then I predict using the predict method, and that gave about a 90% accuracy. Logistic regression model using the logistic regression class, so I fit and predict that one, and that gives about a 94% accuracy. And then lastly, I tried out the random forest classifier, and that gives about a 92-93% accuracy. And then this code that is commented out is what I use to save my model to a file, and these are also just used to save the files. We can jump back to this notebook, and this is where we can download all of the necessary files that we will need. That's what's happening here. This may take just probably over a minute to complete downloading, so I will do that now. And head over to the data exploration section. I mentioned in the other notebook, but I downloaded the files for the lengths of both the real title lengths and the fake news title lengths, as well as the article lengths. This was kind of part of my data exploration section, just to figure out if there is indeed a difference, a significantly different length of fake articles, titles, and article lengths versus real article and title lengths. And as we can see from these charts, there actually is kind of a significant difference in the average number of words in the title. We can see that the fake news articles generally have longer titles, whereas for the actual article length, it's more or less the same. For the data exploration was finding the 10 most common words from the fake news articles, and I did that in the other notebook as well. I just transferred over the results of that, and then here I have a bar chart just charting out those words. You can see the number of times those occur. Trump was the most frequently occurring word, and then you can see the other words that were most frequently occurring. Analysis section of the three models that I transferred over from the other notebook, and here we can see the naive Bayes accuracy and the confusion matrix. You can see the number of correctly identified real articles as well as correctly identified fake articles is in the bottom right. And then these, the top right and the bottom left are the false negatives and false positives. So you can see those for each of these three models I created. And then you can see at the bottom that the logistic regression model was indeed the most accurate. And that is also reflected in the heat map, as the false negatives and false positives are both the most dark, and these are both the most light. And I just have one last visualization of the conclusion, so you can run this and see this mega chart, but this is just another visualization of the confusion matrix for the logistic regression model, which was the highest performing. And you can see that in comparison to the false negatives and the false positives, the model did extremely well identifying real news articles and fake news articles, as shown by the size of these circles. I did get my goal that I set in the beginning of building a model that was at least 90% accurate. I was able to get about a 94% accuracy, and hopefully I can use this model to potentially run it on real news articles that I see, and it's definitely a very relevant tool, so I'm very happy with the outcome of this project.